Hey, welcome back, everybody. Let's go over answers now. Hopefully, this wasn't too hard for you, and you got most of these answers on your own. But if not, hopefully you were able to start it on time and then have time to go ask your teacher for help on the ones you got stuck on. All right, so the first question was, we have these 4-inch lines we drew with our rulers, and it says how many half inches are in 4 inches. Let's go count. I marked every one. There's 1/2, there's another half, there's 2, then 3, then 4, then 5, then 6, 7, 8. So what they're trying to get you to do here is recognize that 4 divided by 1/2 equals 8. Okay, 8 is your answer. Box your answer. Okay, so A is 8. On B, it says, now you mark every 4th inch. How many 4th inches are in 1 inch? 1 inch is right there. You got 1, 2, 3, 4. So there are, you can write in words if you want, are 4 1/4 in 1 whole. Okay, then it says, how many 1/4 are in 2 inches or 3? Well, there's 4 in 1. In 2, there's going to be 4 more. So there's going to be 8. So again, they're trying to get you to recognize 2 divided by 1/4. How many 1/4 fit in 2? 8. And then 3 is going to be 1, 2, 3, 4 more. So that's 12. 3 divided by 1/4 equals 12. Okay, you get that? That warm-up we did was talking about another way of dividing. Something else you could do. We already did 6-3/4. That ends up being 1, huh? All right, 9 divided by 5, you can only get 1 whole. You have some left over, a remainder. You could say 3 point something, but if you're doing 5 pieces per bag, you're filling 1 bag. So that remainder, that's what's left over. Your answer is 1. Okay, you can say 1 with the remainder. Okay, on to Audrey's bowling scores. How many total games? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 6 scores between 110 and 120. None between 120 and 130. She got 3 between 130 and 140, and then this was a good game between 140 and 150. She's got another one. How many total games? 1, 2, 3, 4. 4 and 6 is 10. Plus 3 is 13. Plus 1 is 14. 14 total games. Between what two numbers did most scores happen? I think most people are going to say between 110 and 120. Okay, that's this bar here. Okay, but I wouldn't mind, and I can see you arguing, hey, how about between 110 and 140? 110 and 140? That's 6 plus 3 more. That's 9 out of a total of 14. That's more than half of them between those two numbers. Okay, when you say here you had 6 out of the 14, that's less than half right here. Is that most? Well, it's more than any other one range. Okay, but yeah, so I could see argument. All right, on these here, 7/8 times 5 over 6. And again, I wanted to show you that we did this. Okay, I don't have to go copy these answers because multiplying fractions is easy. You know your facts. This was easy anyway, right? 7 times 5 is 35. 8 times 6 is 48. 2 times 4 is 8. And 13 times 5, I can see that could be kind of hard. 5, 10, 15, 20, count to 13, figure out what it is. But I know 12 times 5 is 60, right? Because that's like on a clock. So 13 is going to be 5 more. 8/65 on that one. 6 squared, 6 times 6 is 36. 7 times 7 is 49. And 4 times 3 is 12. And 7 times 8 is 56. But I'm going to simplify this. And this is one that I showed you how to cross cancel on the warm-up. Okay, remember, I can recognize that a 4 goes into the top and a 4 goes into the bottom. I can make this simpler before I start. 4 goes into the top once, goes into the bottom twice. Now my problem is 1 times 3 on top and 2 times 7 on the bottom, okay, which is what you would do if you simplified this, saying 4 goes into 12 3 times and 4 goes into 56 14 times, but that's kind of hard to see. So simplifying before you start sometimes is the way to go. Oftentimes, if you can, I do it every time. Okay, on to 6-3-7. We started to plot some points, right? 1 over 1 up 1, then over 1 up 5, and now over 4 up 5. I want to connect those dots, and then over 4 up 1, and then connect those dots. And then it says to connect your first dot to your last dot. And if this is a graffiti, they just would have added that 1, 1 again, right, to make you go back there. Now, what are the lengths of each sides? A lot of people want to say this is 4, right, because you went over 4, but it only goes over 1 on this one. So this is 1, 2, 3 wide. How tall is it? A lot of people want to say it's 5, but let's count, right? I'm starting at 1, so 1, 2, 3, 4 tall. So each side is 3 by 4 by 3 by 4, and that was one of the questions. How long is each side? Okay, now it says, what is the area of that shape? Now, since it's on graph paper, you can say, go highlight these squares again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square units. What's the shortcut? Well, what kind of shape is that? It's a rectangle. And when you have a rectangle, you can just multiply the two sides together. Okay. It's also a parallelogram. Parallelogram, you multiply the base times the height. How wide is it? 3 times how tall is it? 4. Now with a rectangle, how tall is it? Is that side. So the area, 12, I'm going to write square units. Okay. And here I'm going to do 3. And to say 3 by 4, you can say it's a 3 by 4 rectangle. Check out how you write that. That means 3 by 4. It's 3 wide and 4 tall. Well, what did I write there? It looks like a multiplication problem, huh? Yeah, so it's kind of cool that and you do that. If you work construction, you're going to write that's a 3 by 4 there. All right, on to 6-3-8. On this one, they want you to draw a diagram so you can show what is 4 divided by 1/3. And I had 4 whole candy bars, and I said, how many 1/3s are in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 divided by 1/3 equals 12. Now, if you do the warm-up, you might recognize that one of the things we're seeing is dividing by one number is the same as multiplying by that second number flipped over. So let's check that out and see if it works. 4 divided by 1/3 is the same as 4 over 1, because 4 is the same as 4 over 1, times, instead of 1 over 3, I'm going to go 3 over 1, and multiplying fractions is easy. 4 times 3. 1 times 1. We'll check that out. It's the same. It worked. Will it always work? I don't know. Let's check out the next one. 6 divided by 2/3. Now we're going to say that's 2/3, that's 2/3, that's 2/3, that's 2/3, that's 2/3, that's 2/3. Well, we got 6 so far, but we got a bunch of leftover pieces. If I put that third with that third together, I get another one. That third with that third together, I get another one. And that third with that third. So I have 6 plus 1, 2, 3 more. That's 9. Let's go back to our hypothesis. Yeah, throwing some science in this math lesson. And that's when we say, well, one of the things I'm recognizing is if I put a 1 under that first number, instead of dividing by this number, I can multiply by that number flipped over. What's 2/3 flipped over? 3 over 2. Now, 6 times 3 is 18, and 1 times 2 is 2. And when I simplify this, 2 goes into the top 9 times. It goes in the bottom 1 time. 9 over 1 is, whoa, I think we have something here. So far, our hypothesis is getting proven correct. Okay, that might be us leading ourselves to a new formula. 5 meters is cut into 1/4 meter pieces on this next one. And it says, how many links will he have? How many 1/4 pieces will he, 1/4 of a meter piece will he have? And can you write that as a math sentence? So we figured out what we're really doing here is doing 5 divided by 1/4. How many 1/4 fit into 5? Let's go check this out. 5 over 1. 5 divided by 1/4 is 5 times, flip that over, 4 over 1. 5 times 4, 1 times 1, 20 over 1. 20. Is that going to be right? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Whoa. Look out, cowbell. I think we got something here. I think we are discovering something here. 5 divided by 1/4 is 20. Okay. That is kind of cool. All right, arrange all the fractions on a number line. Okay, so I have my number line, and I think I remember telling you I made it into sixteenths, right? So 5/8 is going to be 10/16, right? That's 8, 9, 10. I'll put 5/8 right here, right? Because that's 10/16, right? I can go and write 1/16, 2/16, right? If you want, all the way across. 3/16 is going to be right here. Where's 3/8? Well, that's the same as 6/16. 4, 5, 6. 3/8. 16/16 is one whole, right? 1/4 is 4/16. Let's put 1/4 up there. 1/8 is 2/16. 1/8, 2/16. And that makes sense, right? That's smaller than 3/16. 3/4 is 12/16. I got 8, 9, 10, 11, 12. That is 3/4. And 7/8 is like 14/16. I'm going to count backwards from 16, 15, 14. 7/8. Okay? All right. Now, what did you put for your answer best describes how much pizza each person would get if there were 3 people sharing? Would it be 0.33, 33 hundredths? Would it be 1/3? Would it be 33.3%? Well, 1/3 is the one that's exact. These two have been rounded. Okay, so those aren't exacts. Okay, 33 hundredths is not 1/3 of a dollar. It's 33 cents. So when you add 33 cents, 1/3, and another 33, another 33, you end up with 99 cents, and there's 1 cent left over. All right, so that's not exact. You ended up rounding it. Just like pi is not 3.14. 3.14 is an estimate for pi. Okay, 10 times 30 is 300. 30 times 1 is 30. 10 times 3 is 30. And 3 times 1. So I have 300, 30, 30, and 3. 363. Okay? All right, here 300 and 100 is 3 with 1, 2, 3, 4 zeros, 30,000. 3,000, 300, 30, 300, 3,000, 300, 30, and 3. Check this out. I got 3,000. Or 30,000. I got two 33,000s. I got 3 300s. I got 2 30s and a 3. So I'm going to write that like that. 30,000. 2 3,000s, that's 6,000. 3 300s, that's 900s. 2 30s, that's 60, and a 3. 36,963. Okay, hopefully that wasn't too hard. A lot of problems. Good practice though, right? All right. We will see you tomorrow, okay? Or Monday. What is it now? All right. Talk to